Triangles can be proven congruent using deductive reasoning. This is really important. Based on 5 different theorems, and we're going to talk about what they are today. There's side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. A couple of things I want you to keep in mind and you should write down. Inductive versus deductive reasoning. What a statement of congruence is. What it means for an angle or a side to be included. And what corresponding parts are. Corresponding meaning same position. And we're going to keep these words in mind because we're going to come back to them here. So the first thing we're going to talk about is inductive versus deductive reasoning. Inductive reasoning is based on speculation. So if I were to ask you to look at the pattern in the sequence of numbers 2, 4, 6, 8, and I were to ask you what numbers would come next, what 3 numbers you would choose, you would probably say 10, 12, and 14. And the reason we would say that is because 2 plus 2 is 4. 4 plus 2 is 6. And 6 plus 2 is 8. So we could reasonably assume, jumping to a conclusion here, that 8 plus 2, 10 plus 2, and 12 plus 2 would give us those next 3 numbers. Most of the time in geometry, what we use is deductive reasoning, and that's based on what you can prove. You'll always be given some given information. If they tell you that parallelogram ABCD is congruent to EFGH, and then they ask you if side is AB, this side is 10, and they're asking you what is this side, because you know everything over here is equal to everything over here, and because these things match up, these correspond to each other. If this is 10, then this must be 10. And we're going to use deductive reasoning. We're going to look at the indicators here, these lines that are marked. And when they tell us something, based off what evidence we have, what we can prove, we're going to use that to determine if a triangle is congruent or not. And the first way we'll talk about is side, side, side. If you look here, we have triangle ABC and triangle XYZ. And there's one marking here and also one marking here. I'm going to highlight this in blue and this in blue. There is 2 markings here and 2 markings here. And over on this side, there are 3 markings here and 3 markings here. So they have told us that this side is congruent to this side is congruent to this side, and this side is congruent to this side. That doesn't mean that all of these must be the same. This could be 12, this could be 8, and this could be 9. That just means this side would also be 12, this side would also be 8, and this side would also be 9. That doesn't mean that all of these numbers are the same. So because of that, you would write what's called a statement of congruence, which lets you know that side ABC, so triangle ABC is congruent to triangle XYZ. And the reason you would state is because of side, side, side. And side, side, side simply means that all 3 sides have been labeled that way. And we can prove that this side is congruent to this one, this side is congruent to this one, and this side is congruent to that. Another way you can prove triangles congruent is side, angle, side. And here I want you to pay attention to this line has 1 indicator on it. So there's this one. This angle is marked the same as this. And this side is marked the same as this side. And again, we would write a statement of congruence that says triangle ABC is congruent to triangle XYZ. And what I have to pay attention to is what parts correspond. Triangle A, BC as part A here, its angle matches up with angle X. So if I look at the statement of congruence, and this is what you should start paying attention to, what things are in the same position. Well, both of these are in the same position. Before you ever look at a picture, if you have a statement of congruence, it's going to tell you what the picture looks like. It'll let you know that B and Y are in the same position, and it'll let you know that C and Z are in the same position. And one thing you definitely want to pay attention to, I'm going to eliminate and erase everything here, is what the word included means. This angle is included, meaning in between these two sides. These things must come consecutive. This side, this angle, and then this side must match up with this side, this angle, and this side. But this angle has to be included in between these two sides in order for this to be side angle side. That must be the case. Take this and bring that statement of congruence back so you know what that looks like. So triangle ABC is congruent to triangle XYZ, and the reason would be because of side angle side. The next way we would prove a triangle congruent is because of angle side angle. And I see angle E has one marking, side EF has a marking, and side F has two markings here, these two rings. So that's telling me that E and Y match up. Side EF matches up with side YZ, and angle F matches up with angle Z. So when things are in the same position or they match, we say they are corresponding. And so we can prove that these things that I am highlighting are the same. They correspond to each other. And when things correspond, they're in the same position. So angle E and angle Y are in the same position. Side EF is in the same position as side YZ. And angle F is in the same position as angle Z. That lets me know that triangle DEF is congruent to triangle XYZ. So that's what I would write. I would write triangle DEF is congruent to triangle XYZ. And what's the reason? The reason would be ASA. And keep in mind, this side must be included in between these two angles in order for this to say angle, side, angle. This marking must come in between these two things, and we refer to that as included. The next one would be angle side. So angle T corresponds to angle J. Angle U corresponds to angle K. And side UV corresponds to side KL. So I would mark it like that. This blue line corresponds to this blue line. These angles correspond to each other. And angle T corresponds to angle K. And what I do when I write my statement of congruence, I notice that this J and T have to be in the same position. K and U will have to be in the same position. And L and V have to be in the same position. Doesn't matter which triangle you write first. You just want to get these in the same position. So I'm going to write triangle JKL is congruent to triangle TUV. And the reason that is because of angle, angle, side. And these things come consecutively. This angle, and that side. Matches with this angle, and this side. The last way that you prove triangles congruent is specifically unique to right triangles. So when you have a right triangle, the hypotenuse is the side that's always opposite the right angle there. So if I have this marked identical to this, these things correspond to each other. And then they tell you at least one of the legs matches up with another leg. And you have what is called hypotenuse leg. And you can say that triangle ABC is congruent to triangle QRS. And the reason in this case would be hypotenuse leg.